Hey there, it's Shannon Mavchik-Myers, and I am here today to answer a couple of questions from my students about integrals involving transcendental functions. All right, so ready or not, here we go. The first one is this problem here where both of them we need to find the indefinite integral. So a lot of times it's nice to go ahead and rewrite the problem as a product. So what you have is 4 minus e to the x, and that's just to the 1 power, and then times e raised to the negative 5x with respect to x. And so now what we want to look at here is, okay, I've got these two e to the x terms, and do you see that I can, since that 4 minus e to the x factor is raised to the 1 power, what I can do is I can, multiply through to make this into two terms. So this will be the integral of the quantity 4 times e to the negative 5x minus e to the 1x plus negative 5x would make it to the negative 4x. Good so far? Because there's like a 1 here. And when you are multiplying like bases, you add the exponents. So that will be with respect to x. So now what you've got is two different u substitutions if that's how you want to do this. So if you want, you can separate those integrals, and you can bring out in the constant 4 for that first one. So you have 4 times the integral of e to the negative 5x, and remember that dx will multiply to both terms, and so then we'll have minus the integral of e to the negative 4x with respect to x. Good so far? All right, so if we look at the first problem, what would happen is our u substitution would be equal to negative 5x, and so what would happen is we would end up with du is equal to negative 5 dx. Good so far? And so what we're missing in that first one, what we're missing in that first one is a negative 5. We've got the dx, but we need a negative 5. So if we multiply by basically negative 5 over negative 5, you would have a negative 1/5 here on the outside, and then a negative 5. Sorry, I'm smashing this a little bit. You'd have a negative 5. Let's put it here. One more time. I'll put the negative 5 right here. And then we can move that minus over. Good so far? So now we have our negative 5 dx, and so that's going to be our du for the very first problem. The second problem, you'll have u is equal to negative 4x, and so our du is equal to negative 4 dx. And so this time what we are missing is a negative 4. So if we multiply by negative 4 on the inside, we're going to need to, again, I'll move that minus over. We need to have a 1 over negative 4 to balance it out on the outside of the integral. And then we still have this being subtracted. Good so far? Okay. So moving right along, and that of course will give us here we have our negative 4 dx, which ends up being du. So moving right along, we will have negative 4/5, because we have the 4 there, times the integral of e to the u du. And remember I'll just highlight it. I'll highlight it right now. This here, negative 5 times dx was our du. So that's where I got that one. And then minus a minus is plus, so we'll get plus 1/4 times the integral of e to the u. And then this du, right? If you want, you could call it du1 and du2. I don't want to scare you with all the different subnotations, right? So the du for the second one would end up being coming from here. So the negative 4 times dx was the du. Good so far? All right, perfect. So now we'll just get negative 4/5. The result of this integral is going to be e to the u, right? And then you would have, plus if you want c1, and then plus 1/4 e to the u plus c2. Well, a constant plus another constant is going to be just a constant. So I think I will do a subscript. So if we call this du1 and du2 and u1 and u2, u1, du1 and du2, just to be on the safe side. Or you could have used a different variable. So what we're going to end up with is back substituting. We'll have negative 4/5 times e. Sorry about the dogs. E to the u1. So u1, remember, was negative 5x. And then we have plus 1/4 e to the u2. So u2 was our negative 4x plus a constant of integration. And we're done. Good so far? Awesome. All right, so the next item that there was a question on was this integral here. So we have the integral of root x over root x minus 4 with respect to x. Let's take a look at what we have going on. So if we were to let u equal to x to the 1/2 minus 4, right? Then I'm going to do a little differently. If we look at d dx of both sides, what would happen? We would have, du dx is equal to 1/2 x to the negative 1/2, and then minus 0, because the derivative of 4 is 0. So if we were to isolate dx, so I'm doing a little different method here. If we were to isolate dx, what would we get? We'd end up getting that dx itself is equal to 2x to the positive 1/2 du with a little bit of algebra. Good so far? Now, let's check out what we've got. So coming back and making our substitutions in here, this would be equivalent to the integral of x to the 1/2. I'm writing the numerator. I'm writing the numerator in rational exponents, which is what I did over there, over u. And then what was our dx? I'm replacing dx. It was 2x to the 1/2 times du. So all I did for this one is this here is equivalent to the dx, right? So now let's see what we've got. This is going to equal to, well, x to the 1/2 times x to the 1/2 is x, right? And I can bring this 2 outside. So now I've got 2 times x over u du. Good so far? So here's the trick. We need to come back a little bit here. And we know that our u was equal to x to the 1/2 minus 4. So if I work on that, isn't x to the 1/2 going to equal to u plus 4 with a little algebra? And then I need x to the 1, and I need to write that in terms of u. So if I square both sides of the equation, so I have an equation going, then I'm going to have x to the 1, which is what we need, is equal to u plus 4, the quantity squared. And I will go ahead and expand that out. So it'd be u squared plus double the product of the ends, so that'd be 2 times 4 times u, so that would be 8u, and then plus 16. Good so far? So now it's all going to be good because I will have 2 times the integral of u squared plus 8u plus 16 all over u with respect to u. So let's just show you some of the other substitutions we did. Our u, remember, was the denominator. And so then now our x right here was this right here, and we found that using this method here. Good so far? All right. So now, and these are, separate. So now let's see what we've got. If we divide through by u to the 1, we will have the integral of, I'll just write it out, u squared over u plus 8u over u plus 16 over u with respect to u, which is 2 times the integral of u to the 1 plus 8. So we're going to go ahead and split this integral because we have one of our new formulas. So we'll have 2 multiplied to everything. So we'll put a bracket around the 2. And now we'll have the integral, we're adding the integral 16 rather times the integral of 1 over u du. All right, so now we'll have 2 times integrating, we'll end up with u squared over 2 plus 8 times u. That's the first integral all done. And now, what's the next one going to be? Awesome. 16 times the natural log of absolute u. And then we'll close that parenthesis and add our constant of integration. Next up, what we'll be doing is multiplying through by 2 and then back substituting what our u was. So we'll have quantity, what was our u? It was root x minus 4. So quantity root x minus 4 squared. And then we'll plus 8 times root x minus 4 plus 16 times the natural log of absolute root x minus 4 and plus our constant of integration. Oops. actually, I did not multiply the 2 through on the second term. So the 16 turns to a 32, and then the 8 turns to a 16 because you're multiplying all 3 terms by 2. Now, we'll just keep this as root x minus 4 squared, and then plus 16 root x times quantity root x minus 4. Now we've got this natural log that's being multiplied by an even number, and so we'll use that power rule so we won't have to have the absolute value anymore. So we'll end up with the natural log of quantity root x minus 4 raised to the 32nd power, and then plus our constant of integration. And you could simplify this a little bit more because we've got our we could, multiply out the root x minus 4 quantity squared, but this is good enough for now. All right, so thank you very much. I hope that you have a wonderful morning, afternoon, or evening whenever you are watching this show. And if you like what I'm doing, hey, please subscribe. All right, bye-bye.